Welcome students. So in this session we are going to discuss about the serial communication interface. Serial communication in the sense we are going to transfer the data in bit by bit, not as it is, bit by bit we used to transfer. Okay, this will give you the block diagram of serial communication. It consists of sender and a receiver. A sender can transmit the data one by one, a bit by bit in one line to the receiver. That is the serial communication. So in generally we have two types of communication. One is serial communication and the another one is the parallel communication or parallel transfer. This serial communication is nothing but, I told you, the sender will transfer the data bit by bit in one or two lines. Parallel transfer in the sense a byte of data or a word will be transferred at a time. If you are, for example, here you are having 8 bits, so these 8 bits will be transmitted in a separate lines from sender to receiver. Okay, this is the parallel transfer. Coming to the difference between your serial and parallel communication, I told you already that it will be transmitted a bit by bit, that is one bit at a time. Here in your parallel type it is transmitted at a byte or as a word, okay, as a byte or as a word at a time. Okay, so the serial can performed in two methods, either synchronous or asynchronous. Synchronous mode and asynchronous mode, I will tell you later what is the meaning of synchronous and asynchronous. In this parallel communication, it will be transmitted in synchronous mode. Okay, so next point is there is no data skew. Data skew in the sense it is the mislocation of data. Okay, that is your data will not be aligned properly, transmitted properly. So that will not happen in serial communication. Why? Because we are transferring it bit by bit. So that is not possible. No data skew over here. When you are comparing with parallel, data skew is possible. Why? Because when you are transferring a byte or a word completely at a time, there is the possibility of mislocation of data. Okay, so that's what this data skew occurs in this parallel type of communication. The next point is the noise immunity is the value which tells you that how far your device can withstand with the noise. Okay, so that is better in the serial serial communication. Clear? So while you are coming for this parallel, crosstalk occurs. So the noise is more in the parallel communication process. Then your serial communication can tolerate, that is, it can operate with three types of modes. One is simplex, half duplex and full duplex. Okay, simplex in the sense we are having sender and a receiver, that is two devices, right? So a sender can only transmit, it could not receive, that is called as simplex. If it is half duplex, your sender can transmit at a time and for another time period it can receive also. Okay, that is called as half duplex. Full duplex in the sense sender and receiver, both sender and receiver can transmit as well as receive, can transmit and receive at a time simultaneously. So that is called as your full duplex method. But when you are comparing this parallel communication, it will undergo only simplex as well as half duplex values, or half duplex modes over here. Then coming to the design of these communications, your serial communication is more complex when you are comparing with the parallel communication system. So this one is simple design technique and this is the complex design technique. Clear? And while you are comparing the wires, number of wires which we are using in the serial communication, your 1 or 2 lines or nearly 4 lines is more than enough when you are going for the serial communication. And for parallel communication, n numbers of wires are needed. N numbers in the sense how far the bit you are using to transmit, so that number of wires are needed. Okay, so most probably this for example, for best example for serial communication is we can say that the mobile charger or any USB devices, all USB devices, and like slight changes, everything will comes under the serial communication technique. Clear? So I told you that we have two methods of serial communication. One is the synchronous mode and the another one is the asynchronous mode over here. So this will show you the methods of synchronous and asynchronous. Here synchronous mode, in the sense, generally it will set one time period. It will uses the clock. It uses the clock period for this. So for that particular time period, a bulk of data will be transmitted from sender to the receiver. Okay. So a bulk of data will be transmitted in that particular time period, sender to the receiver. That is called as synchronous mode of serial communication. When you are coming to the asynchronous bit of transmission, here you will not use any clock, but the thing is, we will use one start bit and one or two stop bits as per the user interface we are as per the serial communication interface we are using. One or two stop bits will be provided for the stop bits. Okay, so between these start and stop bits we are allocating the data bits over here. Okay, so most probably 8 bits of data will be transmitted serially over here. So in this asynchronous mode of transmission, we are not using clock in order to transmit the data, rather we are using start bit as well as stop bit over here. In synchronous mode of transmission, we are going to use the clock for the transmission. For a particular time period, your data will be transmitted as a bulk from sender to the receiver. So this is the difference between synchronous as well as asynchronous mode of transmission. Clear? So this is the serial frame structure. I told you that you will have one start bit and one stop bit and data bits at the middle. So the start bit is the first bit which will reach your receiver. Clear? So start bit is the logic low signal. So logic low in the sense it is 0. This signal will be 0. So if the bit is 0 is arriving in that if the bit is 0 is arriving in the receiver, then your receiver will understand that some data is about to come from the sender side. Okay, so it is the start bit logic low signal. Now following the start bit, you will get nearly 5 to 9 data bit packets. This part is called as the data bit packets. Data bits. Okay, so it will consist of 5 to 9 bits. Most probably we will send the 8 bits of data at 8 bits of data in this data packet. Okay, so it consists of 8 bit over here. Following this data packet, another bit is going to come, which is logic high. That is, if it is 1, it will be activated. That bit is called as the stop bit. So once your receiver receives this stop bit, it understands that your sender completed its transmission and it automatically stops the reception. Clear? So this is your stop bit is logic high. So initially your start bit will be arriving over here, and the next data bits packets, and next your 1 or 2 bits of stop bit will be arriving between the sender and the receiver. Okay. So this is the method generally what we are seeing in that asynchronous mode. So it consists of start bit, data bits packet and stop bit. Your start bit is nothing but it is always logic low, and it is the first bit in order to start the serial communication, and data bits can be of 5 to 9 bits, and generally we are using only 8 data bits of packet over here. Okay, so it will come after the start bit, and stop bit, this can be either 1 or 2 bits as per the interface. Here this stop bit is always logic high. I told you that, right? This stop bit is always logic high over here. And now coming to the data transmission rate. The rate at which your data has been transmitted per second. So that is called as it is measured in bits per second over here. So totally we are having some standard baud rate levels for that data transmission. It is 1200, 2400, 4800, 19200, 38400, 57,600 and 1,15,200. So these are all the standard baud rates which we are which there are in support. Okay, so now here we are going to use up to 9,600 baud rates level over here. Okay, so in So, what is the meaning of baud rate? Baud rate at which the information has been transformed in the communication channel. The baud rate is nothing but the rate at which the information has been transformed in the communication channel. So, the rate of information transferred in a communication channel is called as the baud rate. Okay, so your receiver should know the baud rate in order to receive the data properly. So it is happening over there. So generally, for example, if you are saying 9600 baud rate, it shows that your serial port is capable of transfer of maximum 9600 bits per second. Okay, so that's what we are saying, that as a 9600 baud. Clear? So this is the baud rate, that is the meaning of baud rate and why we are considering those baud rates and all. So now coming for the calculation of baud rate, we have actually we have seen the two sets of frequencies previously. One is the generated oscillator, the generated frequency from the oscillator. Another one is machine cycle frequency, right? So in that, when you are taking, that is when you are generating the frequency, we are generating it of 11.0592 megahertz. So this is the frequency which we are generating from the oscillator. This frequency will be divided by 12 in the machine cycle in order to generate 921.6 kilohertz of frequency, which will be used by that instruction. Clear? And when we are going for UART, UART is nothing but the universal asynchronous receiver transmitter, where we are using in this serial communication technique, right? So in this UART, we will use 28.8 kilohertz of frequencies. Like generally your machine cycle frequency, which is nothing but MC clock will be divided by 32 in this UART. Okay, initially it was divided by 12 in the machine cycle, and then it will be divided by 32 in the UART cycle. In order to, this frequency will be used by the UART. So 28.8 kilohertz of frequency will be used by the UART interface. Clear? So this frequency which has been generated, then it will be transferred to the timer in order to used by the timer 1. Clear? So generally in that timers, we have timer overflow flag. We have discussed that in the previous session, right? So this timer overflow flag will be set for each and every 3 cycles in the timer. Okay. So in order to that, the frequency which is arriving over here, that is T's clock, will be divided by 3 in order to used by the timer. Okay, so this, after all these calculations, all these division factors, how you will be allocate this baud rates into the programming, in the sense, actually 9600 baud rate will be specified as FD in the TH register, and 4800 baud rate will be specified as FA in the TH1 register, and 2400 baud rate will be represented as FA in the TH1 register, and 1200 baud rate will be represented as E8 in the TH1 register while you are programming, during the software programming. Okay. So this is the calculation of a baud rate as well as your different baud rates, how we are using in the programming over here. So now coming to the types of serial communication. Okay, so previously we have seen, in this we have seen the UART, right? So we have concept in baud rate calculation itself. Generally it is one type of protocol where we are using in the serial communication. So we are going to look at about what is the meaning of UART and what are the pins and signals which is present in it. Okay. So coming to the types of serial communication, we can, instead of saying this as a type, we can say that as a protocols also. So we have 6 protocols, 6 different protocols of serial communication technique. One is RS-232, RS-485, Universal Serial Bus USB, Control Area Network CAN, Serial Peripheral Interface SPI, I2C, which is integrated circuit. Okay. So in this RS-232, RS-485 represents the UART. Clear? UART is nothing but universal asynchronous receiver, transmitter. Okay, it represents the universal asynchronous receiver transmitter. As the name itself, it suggests that it is going to use the asynchronous mode over here. Okay, automatically, and obviously it is a full duplex device, and this will be a full duplex device over here. What is the meaning of full duplex? Sender and receiver both can transmit and receive simultaneously, right? So you are going to use this full duplex. In this session we are going to discuss only about this UART. Clear? So generally RS-232 is nothing but it gives you peer-to-peer communication. It gives you the peer-to-peer type of communication. It is very basic communication method which will happen between the two devices, and this can communicate up to 80 to 130 feet. So it can communicate the distance from 80 feet to 130 feet as per the data bits as well as the cable type which we are using. So it depends on the data bit rate as well as the cable type which we are using. So depends on that, the distance of usage will vary. Okay, it is as the name suggests, it will use the asynchronous mode of transmission with full duplex device. It is also a full duplex device. Okay, then coming to that types of your UART, it has two types of connectors. One is DB25 and the another one is DB9 connector. So first we will see what is the DB25 connector. Both are same, but the number of pins will be different. In this pins and signals of DB25, in the top you are having 13 pins and at the bottom you are having 12 pins over here. Okay, so it consists of two types of connectors. One is DB25P and the another one is DB25S. DB25P, in the sense it refers to the plug connector which is called as the male connector over here, and if it is DB25S, it is called as the socket connector which is called as a female over here. Okay, so this is the DB9 type of connectors. So here you are going to consider the topmost 5 pins is present at the top and 4 pins is represented at the bottom. Okay, so what are the characteristics of each and every pins is nothing but this pin number 1 is called as DCD bar. A DCD bar, in the sense data carrier detect bar, is the logic low signal. DCD is nothing but logic low signal. Logic low, in the sense it has to be activated only when the value 0 comes. Okay, so DCD is nothing but data carrier detect signal. What is the meaning of data carrier detect? In the sense, here we are having two components. One is DCE and DTE. Okay, we can say that as host system and target system, or else like a computer and for example, we can have computer as a host system and target system, any other devices, let it be a modem be the target device. So that kind of thing comes under this DCE and DTE. So this DCE will act as a computer and this is called as modem. For example, I am just giving you an example over here. Okay, so this will act as a modem over here. This DCE is nothing but data circuit terminating equipment. This DCE corresponds to data circuit terminating equipment. Okay, and DTE is nothing but data terminating equipment. Clear? So if the serial data transfer occurs between this DCE to DTE, that represents the data carrier detect. Okay, so this pin number 1 is exactly opposite to pin number 9. Pin number 9 is nothing but the ring indicator over here, isn't it? So this ring indicator is the logic high signal. Ring indicator is logic high signal, that is it will be enabled when your value is equal to 1. Okay, if the serial data transfer occurs between DTE to DCE, that is from from target devices to host device, like if modem to computer, then it gives you the ring indicator. that signal is called, then ring indicator signal will be enabled over here. Okay, then coming to the pin number 2, it is called as RxD pin. RxD is nothing but received data pin. Pin number 3 is for transmitted data, that is TXD pin, transmitted data. And pin number 4 is for data terminal ready. Data terminal ready in the sense, if your receiver is ready to send the data, it will then data terminal ready bit will be enabled. If then 5th pin is the ground, and 6th pin is for data set ready. Data set ready in the sense, if your sender is ready to send the data, then it is called as data send ready, and this is the logic low signal. Low signal corresponds to, if it is 0, it will be enabled. Then next 7 is to 7th pin is request to send. Request to send in the sense, if the receiver is ready to receive the data and it can receive. If it can receive, it will ask the sender to send the data at a time. Okay. So if sender does not transmit any data at that time, so your receiver will request to send the data to the sender. So this bit is also called as logic low signal. So it will be enabled when the pin is 0, when the bit is specified as 0 over here. So pin number 8 is clear to send. Clear to send is in the sense, after the completion of transmitting, this data this bit will be set. If it is 0, then it will be cleared. Okay. So then coming to next, we are going to discuss about the registers of the serial communication. So generally we have 3 set of registers. One is serial buffer register, serial control register, and power control register. So serial buffer register in the sense, it consists of 8 bits from 0 to 7. It consists of 8 bits. Generally, if you want to write any data, if you want to transmit any data serially, you can do it only through the serial buffer register. Okay. So initially your data have to be written into the serial buffer register if you want to transmit the data serially. Clear? So that is the use of the serial buffer register. Coming to the SCON register. SCON is nothing but serial control register, where it consists of 8 bits, 0 to 7, it consists of 8 bits. Okay. So here first 7th and 6th bit is specified for serial mode specifier. This bit number 7 and 6 is applied for serial mode specifier, where you can have, since we are allocating 2 bits for this, we can have 4 types of combinations. 4 combinations for that, right? So you can get 4 types of modes in this. For 00 mode 1, mode 0, 01 mode 1, 10 mode 2, 11 mode 3. Okay. So mode 0 in the sense, it is the shift register mode with the fixed baud rate. Your baud rate could not be changed at this mode, but this is the shift register mode. Shift register mode in the sense, whenever initially you are transmitting the data serially, right? So it will be the shift register will be connected with it. So it will be as a parallel format. So that is called a shift register mode. It will be displayed parallelly. And in this mode 1, it is used as a 8-bit UART. So 8 bits is used over here, and it has determined baud rate. Determined baud rate in the sense, you can vary the baud rate as per the user requirement. And this one is mode 2. Mode 2 is for 9th bit of transmission of UART. So it is also a fixed baud rate. You can't change the baud rate value. And if you are going to mode 3, it is also for 9th bit UART only, UART with timer, but with determined baud rate. Determined baud rate in the sense, you can vary as per the user requirement. Okay. So this is for 8-bit UART, and these two are 9-bit UART. Okay. So this is the disadvantage. Actually, the main disadvantage of UART is you can transmit only up to 9 bits. Beyond that, transmit. So that is the one disadvantage of your UART over here. Okay. So in this SCON register, next coming to the bit number 5, this SM2 is nothing but this bit will set if, for example, if you are using many devices, many peripheral devices with your host system, with your computer, then this bit will be activated. SM2 bit will be activated. That is, if you are supposed to use multiprocessor communication, Okay, multi-processor communication in the sense, if with the computer you're adding some many peripheral devices, then this bit will gets activated. Okay, bit number 4 is receive enable bit. Bit number 4 is REN, receive enable bit. So whenever you're initializing the SCON register in the programming, whenever you are initializing the SCON register, this receive enable bit has to be initiated, it has to be enabled. Okay, so if this bit is 1, this receiver will be enabled. If this bit is 0, the receiver will be disabled over here. Okay, then coming to the bit TB8 and RB8. Okay, this TB8 and RB8 is nothing but the 9th bit. This is the 9th bit of transmission. Generally your UART can transmit up to 9 bits, right? So this is the 9th bit of transmission. When it will occurs in the sense, for example, if you are considering that your error has to be specified in this, error code has to be specified in this bits along with your data, then we have seen one bit in the program status word register, which means that it is the priority bit. Priority bit we have seen in the program status word register with the representation of P, isn't it? So that bit has to be specified, that parity bit specified, that parity bit will be specified as the 9th bit in this transmission along with your 8 bit of data. Okay, so at that time we are using this TB8 and RB8. Okay, this TB8 is nothing but transmit bit, it is the 9th bit, 9th transmit bit. So if we are transmitting one 9th bit, then automatically we have to receive that bit also, isn't it? So that's what we are using RB8 also over here as a receive bit, 9th receive bit. Okay, so where we are using this TB8 and RB8? In order to specify the error code, we are using the parity bit as the 9th bit in this UART serial communication. So here this will be taken as 9th and it will be transmitted along with your data packets, and this has to be received along with the data packet in the receiver side also. So that's what we are using this RB8 also along with that transmit bit. Okay. So this TB is nothing but transmit bit and RB is nothing but the receive bit. Okay. And next coming to the TI and RI flag. Here generally your serial port can generate the interrupts also, right? So when it is generating the interrupts, it has it has allocated with the 2 bits over here. One is TI bit and the one is RI bit. TI bit in the sense it is the transmit interrupt flag. Okay, TI is transmit interrupt flag and RI is receive interrupt flag. Okay, when this bit will be in set condition, in the sense whenever you are transmitting the data or else any byte of data, if the transmission has occurred properly, then this TI bit will get set, will become 1. If the transmission completed successfully, TI bit will get set. Okay, if you are taking this, if the reception of those transmitted bits occurred successfully, then RI bit gets set. Okay, if transmission completed successfully, TI bit will get set. If reception completed successfully, RI bit will get set. Okay, so this is the usage of receive interrupt and transmit interrupt, and these 2 bits can be set only through the hardware, and it can be enabled. It can be enabled through the hardware. Sorry, these 2 bits can be enabled through the hardware, and it can be disabled only through the software, that is by the programmer. Disabled only through the software, that is by the programmer. Okay, so beyond that you could not disable these 2 interrupts by using the hardware. Okay, then this is the mode shift register mode, that is mode 0, how the data are getting transferred. So once, see, this is your RxD is nothing but receiver pin, TXD is nothing but the transmitter pin, transmission of data. So 8 bits is getting. So after the completion of proper transmission, your TI, that is interrupt flag, transmit interrupt flag is set to 1. Isn't it? As we have seen all those things previously. So all these data which has been transmitted serially has been received parallelly over here by using the shift register. And after the proper reception, your receive interrupt bit also enabled as 1. It has been set as 1. Okay, so this is the shift register mode. And next you are coming to the 8-bit UART mode. It is, since it is 8-bit UART mode, it will have one start bit, one stop bit. This is with the low signal, this is with logic high signal, and 8 bits of data will be transmitted, and after the successful transmission, your transmit interrupt flag will set to 1. Okay, this is the transmission part. In reception part, your start received and following 8 data will be received and your stop bit will be received. After the reception of data properly, your receive interrupt will set to 1. Clear? So this is all about your 8-bit UART mode. The difference between 8-bit UART mode and 9-bit UART mode is, here you are having start bit, the same start bit 0 and the stop bit as 1, and 8 bits of data will be followed by 0, that is followed by start bit. Along with that 8 bit, one error code bit, that is one parity bit will also be accommodated over there, which is nothing but TB8. Okay, so that TB8 bit is allotted over here as the 9th bit. Okay, so after the reception of all bits, your transmission interrupt flag has been set as 1. Okay, now we are going to check for the reception. So your start bit has been received, the 8 bits of data has been received, and for this 9th bit you have received the receive bit also. RB bit of 9th bit of receive bit, 9th receive bit also arrived over there. So stop bit has been arrived. So after all these functions, the proper reception completes. So hence your receive bit has been, receive interrupt bit has set to 1. Okay, so this is the transmission of, this is the serial port transmission which occurs in mode 0, mode 1 and mode 3. There is no difference between mode 2 and mode 3, only difference is your baud rate will be varied as per the usage. Okay, so in this mode 2 you can have only the fixed baud rate, in mode 3 you can have the variable baud rate. Okay, so that is the only difference between your mode 2 and mode 3. Clear? So now coming to the programming session, how you have to program for data serially as well as receiving the data serially, we have to look over that. So in order to transmit, first we are going to see the transmission of data. How we are going to transmit the data in the sense, initially you have to initialize your timer mode register. Okay, timer mode register have to be initialized, and TH1 register has to be loaded with the baud rate value, and your SCON register also have to be initialized. After initializing all these process, your timer has to be started. Clear? After initializing the timer, if the transmit interrupt flag is set, it has to be clear first. So we have to give the command called clear TI in order to clear the transmit interrupt flag. After that, the character which you want to transmit serially, that has to be written into the SBUF register. And after writing to that, it has to be check on, that is TI flag bit has to be check on continuously until it will get set to 1. So after, if it gets set, it has to be cleared and the program has to be repeated in order to get the continuous result. Okay, so that we will discuss, we will see that with the example. See, I am going to take one example, that write a program for the 8051 to transfer the letter A serially at 4800 baud continuously. Okay, it has to be transmitted continuously serially with the 4800 baud, and what has to be transmitted? The letter A has to be transmitted. So what is the first step we have to do? We have to initialize the timer mode register, we have to load the baud rate, we have to initialize the SCON register, and we have to start the timer. So these four things have to be done first. So the timer mode register with mode 1 has been initialized. How you can analyze which mode has been generated, which mode has been initialized? By using this hash 10h. Okay, it shows that your mode 1 has been initialized over here. So this move th1 hash -6, in the sense this hash -6 corresponds to 4800 baud rate. These are all predefined. So this hash -6 will give you the 4800 baud rate. So that has been loaded into the th1 register. Clear? And move scon hash 50h. This hash 50h will tell you that your scon register has been enabled and receiver also enabled. That is REN bit has also been enabled. Okay, and now I told you, in order to start the timer, what is the instruction we have to perform? Set B TR1. So set B TR1 is to start the timer, and next you are going to do the process. You are going to transfer letter A serially. So first you have to write this letter into the SBUF register. So move hash A, that is data A is nothing but a data, to SBUF register. Okay, so when you have written into it, you are going to give this function jnbt1, where if you give this instruction jnbti, sorry, this is ti, not t1. So if you give this instruction jnbti, automatically your transmit interrupt flag will be transmit interrupt flag will be checked continuously until the A has been transmitted serially over there. Okay, once if the transmission completes, this TI flag will set, right? So after the complete transmission of A, your TI flag will get set. Once if it gets set, then clear that TI flag, which is nothing but transmit interrupt flag, and again it has to move on to the same procedure. So why we are giving this again function over here? In order to repeat it continuously, you have to transmit the data continuously, right? So you are giving the continuous data transmission over here. Clear? So this is all about the transmission of letter A serially at 4800 bauds. So we will discuss one more program with it. You are going to transmit, now we are going to transmit one message, which is nothing but yes. Program to transfer the message yes serially at 9600 baud, 8-bit data with the one stop bit. 8-bit data with one stop bit, in the sense mode 1, right? So do this continuously. You have to do it continuously. So what are the things you have to do first? You have to initialize with mode 1, and next you have to load the baud rate value. Next you have to initialize the scon register with receive enabled bit, and you have to start the timer. So these are all the very basic instructions which we have to give. So you have initialized the mod register with mode 1 and loaded, that is hash -3 gives you the value of 9600, which is nothing but the baud rate which is given over here. Okay, so this one is loaded into th1, and you have initialized scon register with REN, that is receive enable bit, and 8-bit one stop bit. This is a given over here, and with the set B instruction, set B TR1, your timer has been initialized. Now you are going to move the first bit, which is nothing but A2. You are going to write this Y in accumulator, okay, and then E in accumulator. Clear? And again S in the accumulator. So one by one you are transferring the bits to the accumulator. Okay, after transferring all these bits to the accumulator, from the this is the subroutine program. So from this accumulator, the value will be loaded to the SBUF, the return into the SBUF register. Okay, if this data has to be transmitted serially, so that has to be written into the SBUF register first. So first from this accumulator you are going to load the given values into the SBUF. Okay, so while it is transmitting the data, you will be keep on checking by using this command jnbti. You will be keep on checking the ti flag. If this gets set, then we can understand that your message has been transmitted completely. So once if this bit gets set, this will be cleared by using the clear ti bit, that is clear CLR ti bit. It has to be cleared once it gets set. So it will be transmitted completely and again returned to the main program in order to continue the transmission of S message. Okay. So this is the mode of transmission what we are looking over here for, clear. So the next coming to the receiving of data, how we are going to receive the data in serial manner. So as like the previous case, we have to initialize the mode register and you have to load the baud rate in the TH1 register and the SCON register have to be initialized and timers have to be get started, and after that if there is any RI flag from the previous programs, if there is RI flag is set, that is receive interrupt flag is set, then it has to be cleared. So we have, by using the command CLR RI, we have to be cleared this instruction, and if this RI flag bit is monitored, once if this RI flag is set to 1, then we can understand that all the data have been received properly. So if this RI is equal to 1, your SBUF register will be, the contents in this SBUF register will be moved to the proper place. So this process have to be repeated if the programmer needs. So we will discuss with one type of program with it. So program the 8051 to receive bytes of data serially. To receive bytes of data serially and put them in P1 So your data has to be stored in P1, that is port 1 register. Set the baud rate at 4800. Your baud rate has to be set at 4800. 8-bit data and 1 stop bit. 8-bit data and 1 stop bit corresponds to your mode 1 operation, right? So here for that you are going to start with the initialization of timer mode, that is timer 1. Mode 1 has to be initialized by using the command move tmod, #10h as like the previous case, and this -6 will give you the 4800 baud. So that has to be loaded into TH1 and SCON register initialized with the RE along with the REN bit, and your timer has to be set B TR1. Okay. So now your program begins. Now initially your RI bit starts to, you have to start, that is you have to start checking the RI bit initially. Okay, because your transmission bit is completed, right? Your transmission is completed. Now you have to start checking the RI bit, that is receive interrupt bit. After that, the transmitted data, where the transmitted data will be stored? In the previous case, see in the previous program, all your data which has been transmitted, the data A has been transmitted and it is kept in SBUF register, right? So while you are receiving, what will be the process? From SBUF we have to take it to the location where we need, right? So in this we are going to do that. See, in this SBUF register we are going to write the value in this A register. Okay, so the value which has to be stored in P1 will be present in SBUF register. So only because of that, from SBUF we are going to take it into accumulator. Clear? So from that accumulator, the data will be directly stored into the port 1 register. Since in the program they have given that you have to store the data in P1. Clear? So that will be stored in the P1 register. After storing all these, that is after receiving the data in P1, so who is the sender? Sender is completed, the host system. So receiver is the port 1, right? So in this port 1, after if it receives properly, then the clear bit, the RA bit will set over here, and after that the cleared RI bit, that is C by the instruction CLR RI, that is receive interrupt. Okay, we will clear that. So if you are making it as a loop, then this process will be repeated continuously. Clear? So this is all about your transmission and reception of the data in serial format. Clear? So in the next session we will discuss about the topic 8051 interrupts. Thank you.